Hi, good morning all. Myself Ria Baby and I am here to discuss with you about linear inequations and how you are and I hope that you are all fine. So let's start our class. Linear inequations. Before going through the topic, let me recall you something. So do you know what you mean by an equation? So let's go through some examples. A statement of equality between two expressions involving a single variable x with highest power 1. So do you notice that what is our topic? That is linear inequality. So find the word linear. Linear means the variable in the equation, the highest power of the variable in the equation must be 1. Then we can say that it is a linear equation. Now come to what do you mean by an equation? It's a statement of equality. It is a statement of equality. That means there should be an equal sign. Equality between two expressions involving a single variable. So we have some 2x equal to 5. 2x equal to 5. This is an equation. 2x plus 3 equal to 7. This is another equation because this shows an equality between two expressions, and here we have the equal sign, here we have the equality sign. So this is called an equation. So from this we can define a linear inequality. So linear inequality means a statement of inequality between two expressions. Before what we say about equation, it's a statement of equality. Here we are saying that it is statement of inequality between two expressions involving we are discussing about a single variable, in a single variable with the highest power 1. Why we are saying that with the highest power 1? Because here we are discussing about linear inequality. So since the highest power of the variable should be 1 for the linear inequality. So come to some example here. X is greater than 2. That means there is no equal sign. So for inequality we are using greater than, less than, greater than or equal to, less than or equal to. So we are using these four symbols to show the inequality of a statement. So what do you mean by a linear inequality? It is a statement of inequality between. Inequality means instead of equal to, we are using these four expressions, that is less than or less than, greater than, less than or equal to, greater than or equal to. The single variable and the highest power of that variable should be 1. So here I am giving three examples. X is greater than 2. So there is no equal to sign. So this is an inequality. Here x is greater than or equal to 1. Here consider 3 into 1 minus x, which is less than 2 into x plus 4. Here also between two expressions there is an inequality and the highest power of x is 1. Therefore this is an example of linear inequality. Now how to solve the linear inequation? Linear inequations. You already know how to solve linear equation. Whenever you solve a linear inequation, mainly you need to understand that when it is different from solving a linear inequation. But most of the time the method of solving a linear inequation is same as that of solving a linear equation. But for sometimes there is some difference out there. So if you notice and studied the difference thoroughly, then you will not face any difficulty to solve a linear inequation. So now we will go through the rules for solving a linear inequation. The first rule is on transferring a positive term from one side to other side of an inequation, the sign of the term becomes negative. If we transfer a positive term from one side of the inequality to the other side of the inequality, then the positive term become negative term. Then this is same as that of linear equations. So consider one equation. Consider an equation here. 2x plus 3 is less than or equal to 5. So this is an inequality. 2x plus 3 is less than or equal to 5. So when we transfer this 3, here 3 is a positive term. Here when we transfer this 3 to the right side of the equation, in equation, it will get 2x less than or equal to 5 minus 3. This is what we are doing for equation also. So there is no other change for this inequality. Now come to the next rule. On transferring a negative term from one side to other side of an equation, the sign of the term become positive. This is also the rule same as for the equation. Now consider 5x minus 7 is greater than or equal to 6. Consider this an equation. 5x minus 7 is greater than or equal to 6. Here we need to transfer this minus 7 to the right side of the inequality. So this is a minus term. So 5x is greater than or equal to 6. This minus will become positive. This is 6 plus 7. So we will get 5x is greater than or equal to 13. So this is rule 2. And come to the rule 3. If each term of an equation is multiplied or divided by the same positive number, the sign of the inequality remains the same. If each term of an equation is multiplied or divided by the same positive term, that is the most important word in that rule. If we divide or multiply the equation by a same positive number, then sign of the inequality remains the same. Now consider the equation. 2x minus 7 is less than or equal to 5x plus 3. Suppose this is some inequality. So if we divide throughout the equation by the same number 2, divide by the same number 2, then we will get 2x by 2 minus 7 by 2 less than or equal to 5x by 2 plus 3 by 2. There is no change in the inequality. Also consider 1 by 2x is less than or equal to 1. So this is another inequality. If we multiply both sides by 2, when we will get this become 2 and 2 get cancelled, and this is x is less than or equal to 2. The inequality remains the same. So this is our third rule. So if the most important word in this rule is if we divide or multiply the inequality by the same positive number, then the inequality remains the same. Now come to the next rule. So come to the next rule, that is rule 4. If each term of an equation is multiplied or divided by the same negative number, the sign of the inequality reverse. Now consider an example. Minus 2x is less than 4. Suppose we are dividing both sides of the inequality by minus 2. What we will get x, here we need to write 4 divided by minus 2, and the inequality become reverse because we are dividing it by a positive or negative number. So x is greater than 4 by minus 2. And also if we multiply a negative number with this equation, so multiply this equation with the equation with the minus 1, then what we get, this is 2x minus and minus are cancelled, so it is a 2x, and it is greater than minus 4. So there also the inequality reverses. Come to the next rule. If sign of each term on both sides of an inequation is changed, then the sign of the inequality get reversed. Now consider another example. Minus 2x is greater than minus 4. So if we cancel the minus on both the sides, then you will get x is less than or 4. Then the inequality will get reversed. So come to the next rule. If both sides of an inequation are positive and or it can be both negative, both positive or both negative, then on taking on reciprocals, the sign of the inequality reverses. Now consider an example. X is less than x is less than 5. Suppose consider the reciprocal of this equation. So 1 by x is greater than 1 by 5. So if we take the reciprocal, then also the inequality will reverse. So these are the 6 main important rules for solving a linear inequality. And the first 3 rules are same as that of solving linear equations, and we need to give a little bit importance to these last 3 rules. Now come to one more thing I need to say, that we know that the general equation for a general form of a linear equation is ax plus b is equal to some c. This is the general form of a linear equation where a is not equal to 0. A cannot be 0. If a is 0 means there is no variable exist. Now there is a general form for linear inequality also. So we have 4 general forms. It can be ax plus b is less than c, ax plus b is greater than c, or ax plus b is less than or equal to c, ax plus b is greater than or equal to c. So these are the 4 general forms of a linear inequation. Obviously a should not be 0. Now come to the next idea, that is replacement set and solution set. So for solving a linear inequation, we have given that, suppose in an equation we given that x belongs to R. That means x can be any real number. We can take the value of x from the set of R, means set of real number. Suppose it is in the question, it is given that x belongs to Z. That means x can be taken any value from the set of integers. Only integer values can be taken for solving x. So the set from which the value of the variable x is chosen is called the replacement set. So for an inequality, consider 2x plus 3 is equal to, is less than or equal to 5, is less than or equal to 5, and x belongs to Z. So this is an inequality with the replacement set is Z. The value of x can be taken only from the set of integers. And suppose we are given some value, okay. So next, the subset of a replacement set whose elements satisfy the given inequality is called the solution set. Now consider the solution set. Suppose another example, 2x plus 1 equal to, so less than or equal to 4. 2x plus 1 is less than or equal to 4, and x belongs to set of all natural numbers. So here the replacement set is x belongs to n, that is set of all natural numbers is the replacement set. Now by solving this we will get, what we will get, x is less than or equal to 4. 1 can be taken to the next side, so 4 minus 1 is 3, that is 2x is less than or equal to 3. X should be less than or equal to 3 by 2. X should be less than or equal to 3 by 2. So what is the only value taken for? So this is the solution set. Set of all natural numbers. Set of all natural numbers means 1 is less than 3 by 2. So only 1. 2 means it is greater than 3 by 2. So 1 is the only solution set. This is the solution set for this particular problem. So replacement set means the set of all possible values that can be taken for x, and the solution set is the number of means the values of x that satisfy the particular inequality is called our solution set. That's the difference between a replacement set and solution set. Obviously, the solution set is a subset of replacement set. Now, if we show graphically, if we draw graphically the representation of a solution in a number line, the darkened circle on a number indicates the number is included in the. Suppose consider number line. Consider the if it is given that the solution set this is suppose this is 1. Obviously, here it is 2, 3, 4. Okay, 5. Okay, so this is our number line. So the solution set is given as here it is darkened circle and it goes through up to 5. 5 also darkened. That means the solution set includes 1 and 5. The solution set is 1, 2, 3, 4, 5. Okay, if we draw another line and for 2, 3, 4, or 5, and I have given here a hollow circle and it goes this is the solution set. Here it is darkened circle. That means here we have a hollow circle. That means the number 2 is excluded from the solution set. That means the number 2 is not included in the solution set. So for this number line, what is our solution set? That is 3, 4 in between. If we take a not set of all real number, sets belongs to suppose n. If it is given for r, then we can write this solution set as 1, 5, interval 1, 5. And if consider it from x belongs to n, we can write the set as 3, 4, and 5 is a darkened circle. That means it is included in the solution set. 3, 4 and 5 is the solution set. If x belongs to some real number, if x is our solution, our replacement set is x belongs to r, then how we will write the solution set here? Here we will write an open bracket here, that is from 2 to 5. That means 2 is excluded and 5 is included in the solution set. Okay, now come to some of the examples. State true or false. We have given 1, 2, 3, 4 problems. Check whether it is a true or false. So first is x is less than minus y implies minus x less than greater than 5. Just think x less than minus y implies minus x is greater than y. So one here we multiplied it with by minus 1. That means x we have given x less than minus y. I multiplied both sides by minus 1. We are multiplying with a negative number. So what will the sign, the inequality become reverse. So you will get minus x greater than y. So the first statement is this is a true. Now come to the second example. Consider minus 5x is greater than or equal to 15. Then divide by dividing this statement or this inequality with minus 5. Dividing by minus 5. That is also a dividing by a negative number. Then the inequality will reverse. So we will get x. But here it is 15 divided by minus 5. Inequality will reverse. This is greater than or equal to, so it is less than or equal to. That is x is less than or equal to minus 3. Here the inequality does not reverse. So this statement is false. Now come to the next example. Minus 2x less than or equal to minus 7. Here what it does, 2x divided by minus 4. Okay, dividing both sides by minus 4. So dividing by a negative number will reverse the inequality. So minus 2x divided by negative 4 minus 4. Here it should be greater than or equal to minus 7. Okay. Minus 7 divided by minus 4. So should be greater. So this statement is true. Now come to 7 is greater than 5. Okay, obviously there is no variable here. Again 7 is greater than 5. If we take the reciprocal, what will be it get? 1 by 7 is inequality will reverse, is less than 1 by 5, and the last statement is also true. Now come to the next question. Find the solution set of the inequalities. Consider the first example. A given question is 5x plus 3 is less than or equal to 2x plus 80. So, as we do for linear equations, first we take all the terms with the variable to the one side and all the terms without variable to the right side. So, you will get here 5x, here we have a 2x. So, take this 2x to the left side of the equation. Here it is plus 2x. So, taking to the next side, it will become minus 2x is less than or equal to, here we have 18 and here we have 1 plus 3. By taking this plus 3 to the right side, it will minus 3. So 5x minus 2x is 3x. Less than or equal to 18 minus 3 is 50. So you will get x is less than or equal to 15 by 3. That is x is less than or equal to 5. So this is our solution. So here it is given that x belongs to n. So here our replacement set is set of all our replacement set. So our replacement set is set of all natural numbers. And what is our solution set? From this set of all natural numbers, what all integers or what all numbers satisfies this inequality? Here we have 1 is less than or equal to 5, 2 is less than or equal to 5, 3 is less than or equal to 5, 4 is less than or equal to 5, and here we have less than or equal to. Therefore, 5 also included. And this is our solution set. Okay, is it clear for you? And I hope you understand the topic. So the second example, I left it for your homework. Okay, do it as a homework. Okay, thank you all.